Welcome in this new fuzzing video. So today we're going to discuss about JavaScript fuzzing and especially like npm, NodeJs packages fuzzing, and how you can implement fuzzing of this type of code pretty easily using jsfuzz. So that's actually a subject that I already discussed some time ago. Especially it was when I released this blog post about fuzzing WebAssembly parsing library with jsfuzz, and I found like an out of memory bugs using these techniques. So I will let you the link of this article, this blog post right below, but you will already get an idea of what you are capable of finding in addition of what we're gonna do today. So as always, you can directly sign up and register on my Academy, Fuzzing Labs Academy website to get all the content, all the cheat sheet and so on to reproduce at home. I mean, I really invite you to play and take maybe 5-10 minutes to play with it, just to give you an idea. Once you will do it, it will look way more easier than you can see. So as I mentioned, today we're gonna first some JavaScript npm node.js packages. So and we're gonna do that with jsfuzz. So first of all, you need to install jsfuzz. So that's one of the prerequisites. So you can directly take a look at this specific link. That's where jsfuzz is actually stored right now. It's on this GitLab. So you have all the documentation right there. But basically, as you can see, the first target will be pretty easy. But I'm gonna show you that in more detail. Just to mention, if you want to install jsfuzz, you just need to have something as easy as npm I install, and after that jsfuzz. So you can use this one right there, or you can use I think I've also, yeah, you can use this one as well. You know what, let's use the one on the project, and let's see if it's working pretty well, but it should. So right now we're gonna install jsfuzz, so that's the fuzzer, and what we will need is actually to create a fuzz target. So okay, it seems that something was not working properly. Remove an existing file or run. Oh, it's already existing. Yeah, it's because I mean, jsfuzz is already installed for me, so you can just run that actually, and it will maybe reinstall the stuff, or at least it should be okay. Okay, yeah, it's because I already have jsfuzz installed right there. Let me take a look at that. Yeah. So whatever, you can install the stuff just by using that. So then the next part is actually to choose a target. So I selected one specific target, that is omggif. So it's this library. So it's a JavaScript implementation of a GIF encoder decoder. So you can directly take a look at the package on npm and so basically it's a really famous package. As you can see, there is I mean weekly download of like 1 million, so it's not I mean a tiny package in that case. It's a pretty famous one. If you take a look at the GitHub code, you will see something really interesting. That is that there is no update since 2 years. You can see that there is no fuzzing package or something like that. So that could also be a first hint for you to tell, okay, maybe something wrong is happening, and maybe it could be interesting to fuzz this target. The good part is we have some example, so we can leverage on this example in order to create our own fuzz target. So that's what we're going to do. And as I mentioned, a first target for jsfuzz is pretty straightforward. Let's take a look at this one. That is actually the first target for JPEG. So as you can see, we are doing like require JPEG JS. So in all cases, we're gonna replace that by omggif, and then we have the fuzz function and so on. So really straightforward. Just that's the basic, and we're gonna leverage on this piece of code. So let me show you the first target I created. Oh, let me actually just remove the sound of that. Okay, so we have so I created this first target especially, so this one. In that case, I'm leveraging on the this example. As you can see, require omggif, and after that there is like a GIF writer, but in my case I will be more interested about the decoder and not the encoder. So let's take a look. Maybe we will find something interesting, especially GIF reader. This one, GIF reader, is really interesting, and we are providing some data, so that will be in all cases some arbitrary byte that will be provided. So as you can see, require omggif, we have the function fuzz, and then I have some try catch. So for the moment, we will not, let me do that with you. I will actually not, I have the same stuff right there, but I will comment everything just to give you an idea of like the different step. So basically, for the moment, we have some try catch. Let's comment this one. So we will just gonna execute this omggif GIF reader data, and the data will be generated by the fuzzer, and that's all. That will be the most basic fuzzing target that you can have. So right now we need to launch this fuzzing target. So let's do jsfuzz, then we need to specify the fuzzing harness, so in that case fuzz omggif, and then we're going to provide a folder where actually all the inputs will be stored. So I already have one, but let's use a new one, test omg, and you will see the fuzzer running. So right now you can see that what is happening is we are getting an error immediately. And the reason for that is because it's the error from the library. So the library will trigger an exception, and this exception in that case is an error invalid GIF header. So it's pretty normal. Actually, if you can see that the fuzzer just create like an empty array and try to provide some empty array, and the header of course is invalid since there is no byte. So sorry, in that case we want to catch this error, and we want to just ignore this kind of error. So that's where the try catch comes in play. We are doing a try catch. We are catching this exception, and in that case what we're gonna do, it was like an invalid GIF, so we can just let me comment, no, you know what, yeah, let me just take that. What we're gonna do is actually we're gonna ignore if we are getting this error, and by doing that it will be really easy for us, because each time we are triggering this specific bug, this invalid GIF, we're gonna ignore that, otherwise we're gonna throw an error. That's the idea. So let me verify everything's okay. Everything seems to be good. Okay, so let's run that again. And as you can see, we are getting some coverage, some stuff are happening. We are getting, let me zoom in, maybe. Zoom in. Okay. So as you can see, we are getting some coverage. So it seems that the fuzzer is finding some new inputs that can be processed. The corpora is going up, that's the second stuff, and then the execution per second is also growing, so around 18,000 execution per second on a single core in that case. As you can see, we are triggering another bug. another error, unknown gif, so it's an expected error generated by the library. So this kind of exception are completely legit. It's some valid exception. So it doesn't make sense. It's not a vulnerability at all, since it's the expected behavior. The library will generate an exception. And if I remember, it's even specified right there directly on the GitHub. Yeah, I don't remember where, but it's usually it will be well defined. If you take a look at the omggif, you will see that it will specify maybe the different list of errors and stuff like that. As you can see on the code, throw new error. So it seems that he's always using this terminology with some specific messages. So that's the idea. In one way, it's bad for us, because if this library was written a bit more properly, he was using like a custom error in JavaScript, error exception, like I don't know, like omggif exception or omggif error, and in that case it was possible for us directly to catch this exception, and if this exception was an instance of this one, we can just ignore this one, and that's all. Since it's not done that way, that means we will need to just catch all those different messages. So hopefully, as you can see in this previous example, I was catching so invalid GIF, but I have not put like all the error message. I have just put the beginning, and it was working pretty well. So in that case, we can also do the same with unknown, but we will do even better. We will just catch if it's starting by invalid GIF. If it's starting by invalid, we can just ignore that for the moment. Or so invalid GIF or unknown. If it's starting by unknown or invalid GIF, we're gonna catch that, and we're gonna ignore it. So let's run the fuzzer again. So it's running, and we are catching another error. So in that case, invalid block size. So you can see that it's not invalid GIF, but invalid block size. So let's ignore all the stuff that are starting by invalid. So those one are actually redundant. I mean, this one is part of this one, I would say. But whatever, it doesn't really matter for now. So let's do that again, and let's run the fuzzer again. So as you can see, we are going a bit deeper. We are getting more and more coverage, so that's really nice. And at some point, we should trigger this issue. In that case, you can see that we have a type error. So a type error is not something, and especially if you take a look at the message, it's not something that is expected to be triggered by the library. So in that case, we successfully find a bugs inside this library, since we have triggered an exception that is not usually and that is not expected or generated by the library. So that's nice, perfect. So we can, if we want, and we're gonna do some quick analysis of this one, but basically, if for the moment you want to continue to do the fuzzing on that, but you don't want to catch this exception again, you can use this notation like e instance of type error. So you will just catch all the type errors and throw them and just ignore them. The downside of that is in that case we're triggering a type error in I don't know, at this line 1736. If we're triggering a type error in other part of the code, it will be ignored as well. So that could be an issue. So if we want, let's rerun the stuff, and you will see that the fuzzer will actually continue and try to find some other bugs and so on and so on. So in that case, we are still reusing the same corpora over and over. That's because we have provided a folder. Of course, since we are dealing with a well-known format that is a GIF, it could be really interesting to just grab some existing GIF from internet and provide that as an input to the fuzzer, because it will, based on this input, it will mutate them and provide them to the fuzzer. For the example, I should have something in my C and C++ training. I should have some corpora database, and do we have some? Yeah, we have some GIF corpus. Yeah, so we can just copy that. As you can see, the corpora is 35 for the moment. Just copy that in test. Oh my god. And let's run the fuzzer again, and we have a lot more corpus, and it's running. So basically it seems that we are getting more coverage, so that's nice. That means some new input I provide are actually triggering some new coverage, so that's pretty nice. Okay, so basically you just let the fuzzer run. As a reminder, we are on a single-threaded process, so that will not be too much impactful. You can just run that on the side and see if we are triggering some bugs. Something that could be useful is actually to use some specific option of jsfuzz. You can see that you can, for example, provide only ASCII. You can specify the memory limit. You can specify some timeouts and so on. That's a bunch of stuff that are possible. There is even a regression option that will basically do like a dry run on every file that you have. So that could be something really interesting, because for example, by the time you are generating a proper corpora, you want to keep that on the side, and each time you are modifying the library, it could be interesting to have as part of your CI continuous integration, sorry. You maybe want to run jsfuzz with the regression flag to just iterate over all those existing corpora and see if you are crashing anyhow. So that's the idea. So let me just comment back at this stuff. We should trigger this vulnerability pretty immediately. So it's a type error. We have the X value, and basically the good part with that is first of all, it's already all the crashing sample is this one, so you have all the bytes directly there, so it's stored locally on your system. But in addition to that, you also have the X value. The next step when we are triggering a crash like this one is to reproduce the crash, and in that case you're gonna use this hexadecimal string value to create a minimal reproducer. So that's what I've done right there. So let me show you. I create a basic reproducer, so it's this one. So basically I'm doing require omggif. I'm creating a buffer from this hexadecimal string. I don't know if it's the same one. No, it's not the same one. So I just trigger the same bug with another one. We can actually use this one as well. Let me copy that right there. Okay, so it looks similar. Actually, there is some bytes that are not the same, but it's all pretty similar. And then we are calling omggif reader with the data. So let's see if we can reproduce that. So NodeJs, then we are using repro omggif TypeError.js, and if we are running the stuff, as you can see, we are triggering an issue inside. We are still triggering the same issue, and in that case we are getting as an information that it's a non-graphic control label. And okay, so it seems that we are actually triggering an issue in this specific line that look similar to like a error message. So it looks like we are triggering some error message, maybe an exception, but when we are creating this exception, we are actually trying to access and using some data that shouldn't be used. So we have some undefined value, and we are trying to do a toString over this undefined value. So it's the 459 line. Okay, let's take a look at this new one. and see if we're triggering the same one. Yeah, it's the same one. So as you can see, multiple crashes will actually lead to the same bugs. So congrats. So ideally, once you are able to trigger that, the best things to do is to report the bug. So I will actually report this bug immediately to the GitHub repository. But if this bug is fixed by the time, or if you want to play with that and maybe find some other one, I really invite you to do so. So as usual, you will find everything, all the code, all this cheat sheet I've shown you with like all the different steps with run the fuzzer, the stuff, and the reproducer. I mean, everything will be right there. So basically, you can just take a look at that and reproduce using those command lines. So everything is available there, and if you need, don't hesitate to reach out to me on the comments and let me know what you would like to see next for fuzzing or reversing or stuff like that, and I will try to make you happy. So see you next time, and happy fuzzing.